Recessed can lights need to be airtight, IC rated, and sealed to the drywall. Fixtures mounted in the ceilings, however, of assemblies that are not part of the thermal envelope are exempt. So we see this a lot. You can see that particular recessed can has a label airlock. It probably has a little piece of foam with a wire service enters the can from the back side. The trim kit probably has a little piece of foam that comes with it. I would recommend that that still be sealed somehow with either caulk after it's adjusted. I don't typically see these airtight cans come through. Mike, I know you see this too, these recessed cans with the trim kit. Is it really airtight? And somewhere here I have an IR photo that tells me otherwise. But again, we're talking about the can lights that are installed into somewhere in the thermal envelope. We're not talking about the ceiling between floors of conditioned space to conditioned space. There it is. That's an airtight can with the blower door running.
So let's look at this. Does the energy code require fluorescent lighting? Well, most of you answered this trick question incorrectly, or maybe correctly depending on your perspective, because the code does not mandate fluorescent lighting. It does give you very little choice but to use fluorescent lighting. Because a minimum of 50% of the lamps in permanently installed fixtures have to be high efficacy lamps. Now, I don't think the code writers envisioned you're putting half of the bulbs in a chandelier as compact fluorescent candelabra lamps and the other half is incandescent candelabras. But overall, half of the bulbs, half of the lamps in permanently installed fixtures have to be high efficacy. What are high efficacy? Compact fluorescents. T8s are smaller. Everybody knows what the T stands for, right? They don't. T actually stands for tubular. But a T8, you can say T stands for thickness, because in eighths of an inch. So a T8 lamp is a 1-inch diameter tubular fluorescent lamp. A T5, 5/8 of an inch. Now you can win on Jeopardy for sure. Or lights meeting these requirements. What lights meet these requirements? Well, one thing we can tell for sure is the standard incandescent doesn't meet those requirements. And that's why next year, supposedly, 100-watt light bulbs are going away. In 2 years, things above 40 watts, maybe 60, are going away. So it either means hoard or make other plans. Now, you see some, I guess this particular chart doesn't show LEDs. LEDs are not necessarily as highly efficient as you may think they are.
Building envelope, okay. The insulation, now this is comparing it to the previous code. Insulation values have increased, you bet. The charts have simplified, yes. The recessed lighting, like I said, now has to be sealed, you bet. This is some pictures, an infrared picture of a bad case. All right, this case right here, what was happening is the roof was leaking. It snowed this winter, right? We had lots of snow this winter. I saw some buildings come down because of this snow on the roof. A flat roof, oh, by the way, is a bad idea. In the Northeast, a flat roof is a real bad idea because it snows here, it melts, the roof drains clog, and then you have leakage. The leakage stains the tiles. I'm looking around to see this is pretty in good shape. They stain the tiles. All of a sudden you have electric shocks here. You got a guy up on the ladder pounding it away at an ice dam, trying to relieve the pressure. You take an infrared shot and you can see what's going on. Bad news. You're dumping a lot of heat up into the plenum, which further melts the snow, causes ice dams. Bad things happen. All right? So this, in fact, I'm very much in favor of this part of the code with regards to recessed lighting. Making sure we get rid of these, not so much these, but the ones that have incandescent bulbs in them. To get well beyond the code, these guys work very well. Has anybody used one of these LEDs? What do you think?
Fantastic.
Yeah. You know, I mean, here's the deal with this. Let me give you the bad news. On the minus side, cost. They're, what, 80 bucks a whack? Something like that. They're quite expensive, all right? So, I mean, that means you're going to replace this with $80 times 1, 2, you know, however many you have in this building, all right? A lot of money. But boy, oh boy. First of all, it gets rid of dumping that heat up into the plenum, which is nice, okay? It meets the code because now you can seal up this fixture and now you've met code. That's kind of nice if you can do that. They are dimmable. They have a high CRI. That stands for Color Rendition Index. Nice and warm. They're good looking light. You know that bluish white, that if you buy cheap fluorescent lights, they're bluish white. What they do is they highlight the gray in your hair and the wrinkles in your face. Really makes you feel good when you go into the men's room and look at this thing staring at you. If you didn't feel bad before, well. Anyways, I like these things a lot. And when I'm doing an energy audit, if I go into your facility and you need a man lift to get at those lights, let's say there's a high school not that far from here. It's an auditorium like this. Do these things have to be unbolted? Just like this. These rows of chairs have to be unbolted if you wanted to get a man lift in here. Well, chances are we're not going to have to do that. A step ladder can get here. What if the ceiling was 30 feet high? You'd have to unbolt rows of seats to get a man lift in to change the lights. All right? That means the price of those lights has gone up. Just slip the decimal point over one place because of maintenance. All right? These things here, these LED, LR6s, LR12s, whatever they are, they do the job. You put them up there, they last 50,000 hours, 80 bucks a whack, but you save it in maintenance. You meet code, which is awfully, you exceed code, actually. And they do long life. There are utilities and incentives. There's some junk out there, so be careful. There are people running around selling some LED products that are junk. So don't be the first one to buy one. When somebody comes to you, especially outside lighting, exterior parking lot lighting. Somebody wants to sell you some LED lights in the parking lot. Ask to see some. Ask to see a job where they're in place. Maybe you won't buy them if you take a look. Yeah?
Where's the crossover in terms of front-end cost versus life cycle? At what point does it become cost-effective?
Well,
Or how do you work with your client to answer that question?
the first thing to determine that, we have to understand payback. Cost divided by savings equals payback. Engineerese, that's what that's all about. The cost can be diminished or reduced if you talk to, hello, utility, how much money will you give me if I put something that's highly efficient in? So they're going to give you some money. So the numerator is reduced. If you have a payback, and in the case of these, I throw maintenance into, because the maintenance is so expensive on a high-hat fixture that I'll throw that in, and we'll basically reduce the maintenance down, reduce the cost down. The payback gets below 3 or 4 years payback, that's a good thing. It is not a simple calculation sometimes when you start throwing in maintenance. And LED stuff is expensive right now. You know what? In 10 years, the LED market's going to have one a day. And we're going to have a widespread LED lighting products all over. Right now, it's just coming at us. So it has to be, you have to run the numbers, and sometimes the answers aren't very good. Okay, this is a picture of a Friendly's ice cream, or maybe I shouldn't say that. This is a picture of a local restaurant. How's that better, right? There we go. Okay, and they said, listen, we have a bunch of incandescent lights, right? And we understand that code, you know, when they have a certain number of watts per square foot in the code, right? You know, it's what the code requires. Okay, we don't think we're meeting code anymore. So we want to upgrade our lighting. We have some money. What can we do? So on and so forth. And they had incandescents, 5,000 watts, thereabouts in the store. They put in these things that I was talking about. They're down to 1,000 watts. For them, it was worth it. For them, they received some money from, I think, Public Service of New Hampshire, and it was worth it. And see this lady right here? right? I don't know if you can see her. It's kind of a crummy picture. Notice she's not in that picture. They fired her to pay for the lights. They didn't really. That's a joke. That's with it, other than to say, sometimes people will say to me, do they meet code? No, you're going to have to tell. Here's one way you can do it. This is, once again, more free software. It looks like this. This is, wait a minute. See this gym right here? This gym, I was mowing my grass one day, and the superintendent came by and said, we have those metal halides in it. The ones you flip on, they hit right. You know, nobody wants to play ball or play under those. He said, gym 1, and I said, it doesn't meet code. I said, don't even do that, because if you want money from National Grid, you have to beat code, all right? Because they'll give you money to do things like this if you can beat code by 15%. So he said, how in the world am I supposed to do that? I said, worry no more on the reindeer. Have I got a solution for you? And let's find the cursor. And maybe it looks like this. Wait a minute. I lost my cursor. There it is. And the show. And go over here. Once again, you go back to the World Wide Web, and you find something that says ComCheck. It's got to be here somewhere. Here it is. And this is put out by the Department of Energy, Department of Energy. And basically, what you want to do, I mean, this isn't really high-tech stuff. This was a gym I was talking about. I just showed you that gym. It had 22 lights. It had 22 metal halides. All right. So I said, listen, you're going to want to change these. And you want to change them to, well, let's pick on New Hampshire. We're in New Hampshire. We're in the town of Antrim. No, we're not. We're in Concord. We're in Manchester. I have a hard time knowing. I used to live in Candia once upon a time. Nice place. Manchester. Put my glasses on. You would fill out all of this stuff. Oh, name, rank, and serial number goes here. What you really need to do, though, is say, all right, according to the code, what do we need for... The code talks about lighting power density, watts per square foot of lights. That's all it is. Add up all the lights, how many watts divided by square feet. That's what the code says. So what you want to do is on this pull-down menu right here, you want to select a category. And you want to select gymnasium. Maybe you could even make this the full screen. There we go. Notice that it says 1.1. According to your code, in your gym to play hockey or to play basketball, you can't exceed 1.1 watts per square foot. That's your code. That's what it's all about. So what does that mean? Well, let's see, Mr. School Superintendent. In my town, we all have multiple roles. It's just a little town. The school superintendent is also the school bus driver. So he has multiple tasks. So he said, well, he says, I wanted to put new interior lighting in, and I was just going to replace what we have, pigtail to pigtail, with metal halides. I said, please don't do that. Here's why. If you put metal halides in, and I know because we looked at the box that they were 400 watters, they were standard, 1 lamp per fixture, number of fixtures 22, and I know, now you know what I'm talking about, right? The round lights that take so long to get bright, they have a ballast. So it's 400 watts plus a ballast. The ballast is about 80 watts, 480 altogether, okay? So you put that in here, 480, and put enter. And notice that, what did I do wrong? Come on. What am I doing wrong here? Notice that it's not working. Notice that, what? Lamps per fixture, 1. We did that. Metal halide. Why isn't it working?
Square footage on the first page.
Square footage on the first page. Thank you. We measured it up. There, red number, 5,400 square feet. The reason I knew that is we measured it. Thank you. So if you go back to this interior lighting, it's going to tell you, notice the red number. Notice this number down here that you can't see is a red number. It says minus 78%. What that means is you have now exceeded the code by 78%. That's thumbs down. No utility is going to give you any money if you exceed the code by 78%. All right? Same with any type of ERA funding. So I said, get rid of those. First of all, they turn all different colors. They turn blue and red and pink. They lose lumens. You can't play ball when there's shadows all over the place. You know the room that we just had the lunch in? Those are T5s overhead. The little skinny guys, that room, those things are really bright. Okay? And they're great to play ball under. So I said, replace those metal halides with the T5s. So you go over this, you right-click on that, and it says delete. Yes, I'm really serious. And what you want to do, those are called linear fluorescents. And you know they're T5s, they're electronic. There's 4 lamps per fixture. If you're not playing under color TV, you can go with 4 lamps per fixture. If you're playing ice hockey, UNH, and you can play under color TV, you need 6 lamps per fixture at center ice. Okay? So that's a factoid. If you're on Jeopardy tonight, you know something. All right. And do you know what the Canadians, anybody here a hockey fan? You watch the Montreal Canadiens play at the center ice in Canada? It says CH. Do you know what that stands for? Center ice. Anybody been around French Canadians? Did I insult anybody? I'm sorry if I did. Number of fixtures, 22. And I know from the GE catalog that a 4-lamp fixture, mirrorized T5s like down here, is 224 watts. So you put that in. 224, hit enter, and notice that it turns green at the bottom. Notice, you probably can't see that. Right down here, God bless you. You're 17% under code. Since the utility requires you to be 15% under code, high fives all around. They're going to provide some money for this. So that's what I told superintendent, do this, please. This is ComCheck. This is all there is to it. I get submittals from architects that have 21 lines, 12 compact fluorescents, 8 LEDs, 6 of these, 12 of that. Adds all up. There it is. That's the number. I can write out big checks to people. Well, I can't. And the utilities can write out big checks to people if you meet the code, meet or exceed the code. You can do this with shell measures. You can do this with HVAC. You take a look at this. It's one of those free software packages. They're worth their weight in gold. So take a look at it. Download it to your computer. It'll make you look smart. There save changes. No, let's go back to here. And this is what we were talking about. And this is the gym here. And no one complained about those new lights, except there was a couple of people that played tennis on Tuesday mornings, and they would look up into the lights as they served the ball, and it would temporarily blind them. And they said, these lights are too bright. I said, well, that's too bad. I don't know. What are you supposed to say, right? Wear sunglasses. I don't know. So, power lighting, okay. Major components. If not ComCheck, then you have to do it out by hand. You can do that. There are many, many exceptions to the lighting code. Here they are. If it's for theatric or medical procedures, or boom, I mean, there's the lighting code portion has many if, ands, and buts. And you read them and you say, okay. Incidentally, exit signs. The code says they have to be 5 watts or less. Did you see the new code regulation that they have to be at ground level now? Did you see that? The military bases are putting them down at ground level. And at first I said, that's kind of stupid because people are going to kick them by accident. However, in the case of a fire, if the smoke is piling into this room, you may not be able to see that. But you'll always be able to see it at ground level. Okay, so that's another question you have tonight. But these are, basically, these are all the if, ands, and buts for lighting. Basically, how to meter code, there's many different things that you can do. We already talked about LED lights. There's ways to get more than 50% energy reduction. It's a wow. And those of you whose benefits are additive, like on a LEED certification, you get certain points for certain things. It's kind of nice to really hit a home run with lighting. Some of it has utility incentives. This is Mass Maritime Academy where I'm doing some work. They have poles that have LED lights, full cutoff, with a photovoltaic panel and a battery. And they're totally disconnected from the grid. That's coming our way. We're going to be doing more of that. The downside to these is they're $6 grand a piece. Do you have $6,000 to spend on an outside light? Not yet. But what happens if we can improve the technology so they come down? Have whole parking lots that are disconnected from the grid. That's a good thing, right? We'll benefit from that. Different things that you can do. I like LED scoreboards. Think about it. If we're maintenance guys, if these are incandescent bulbs, we're out there with a stepladder all the time. Otherwise, the 8 turns into a 3, right, as they burn out, right? So if they're LED, put it up, you're done with it. There's lots of good applications. So very costly, though, at this point. But it's coming down fast. And I'm seeing more and more good installations. reach-in coolers for your Sam Adams beer. Those should be LED now, and they will last on and forever. So lots of good applications to beat code. On the plus side, as far as using high-performance T8s, that's a T8. When we talk about fluorescent lamp tubes, they're this big. Right? For instance, during the Eisenhower administration, they were real big. They were 1.5 inches in diameter. Those are called T12s, 12/8 of an inch in diameter. The T8s are the standard now, and there's a product out now called the high-performance T8. These are ways to get way better than code. There's direct-indirect fixtures, which have a nice uniform light, suspended, pendant is suspended. Basically, the thing that I always recommend to my customers is if you're going to do a lighting job, change them all at once. In this room we're in right now, there's a couple that are yellow there, there's a blue one over here. If you change them all at once, you'll have a nice uniform color. And the maintenance is more expensive than the product. So changing them all at once makes sense. That's called the group relamping. Okay, lighting. What else do we have? Here's a gym with metal halides changed over to T5s. Again, it's exactly the same story that I just went over. It's 40% better electricity. But here's the real winner. You can put a gym that you change to the T5s, like that room down here where we just had our tuna fish sandwich. Those can be on a sensor. They don't mind being turned on and off. The ones that you turn on and take 20 minutes to get the full brightness, nobody will turn them off because they take too long to get bright, right? So if you're talking an elementary school gym, the kids want to go outside and play when it's not raining, basically the occupancy sensor will turn the lights off. Not only will you get the 40% reduced wattage, you also get the benefit of having them on controllers. These are big energy savings. And you know, and again, the code requires 50% on controls. It's one way of getting there. You can't put those things much above 50 feet. In that room there, I don't know how, are they what, 30 feet?
A little less.
A little less? They're fine. They're punching out a lot of light.
They make shadows, though,
Yeah, they do.
compared to the lights with that metal halide in there before.
Yeah, and it punched out a tremendous amount of light. That's right. That's right. And sometimes, I'm not saying that some lighting salesmen are unscrupulous, but sometimes if you happen to run into one, they'll try to sell you underpowered fixtures. So make sure you see one in place before you buy it. All right, continuing along, exterior lighting. The new code talks more about it now than ever before. For those of us who are astronomers, this is a good thing. I'm sick of watching lights trying to light up the moon. We need to have full cutoff lights, and there's different types of efficacies requirements in the code, but they have to be full cutoff. If you put a light out back here to light up the dumpster, a wall pack, and it shines into the neighbor's room, they can ask you to put one of these on. Basically, some type of a hood that will keep it from going into your room. Same with traffic. If you put a light up that cars coming and going are going to be seeing it, you got to make sure you cut that off. Okay, full cutoff is required, and it's part of the code. In my opinion, not very many people have paid attention to it yet. I hope they do. Sky and Telescope magazine a couple years ago did a whole article about a fully mirrored, full cutoff fixture. You can bring it down to 250 watts that used to be a 400 watt that lights up the sky. So in fact, there's some energy savings with doing this. For sports lighting, has anybody used any of the Musco lighting on their sports fields? It's pretty good. I try not to normally recommend one product over another, but the Cape Cod League, where they play baseball with wooden bats, they are using Musco light in their sports fields, and it's a good product. When I'm doing an energy sports field and said, what can we do about this? And you got these big stands, is that what they're called, of multiple lights like the metal halide. There's not much you can do, but you can drop back here if you're using a pulse start metal halide or one of these green Musco lights. green product, 20% reduction, they're a little bit costly.